Let's say that there are 64,000 subscribers to an online fashion magazine, and due to competition, that number of subscribers is expected to decrease at this particular rate. So we know the rate of change of C, that would be C prime of T, where T is the time in months since the new magazine popped up. How long will it take until the number of subscribers to the online fashion magazine drops to 46,000? So again, here we're given information about the derivative, and we're asked about information about the original the original function, the number of subscribers. So we're trying to determine C of t given information about C prime of t. And as you might expect, our first step is going to be to take the antiderivative on both sides of this equation. So if I take the antiderivative on the left side, I'll get C of t. And if I take the antiderivative on the right side, that negative 600 is just going to stick around. But I should take the old power, which is 1/3, and add 1 to it. So I would get 1/3 plus 1, which is the same thing as 1/3 plus 3/3, which is 4/3. And then I would be dividing by that new power, which is 4/3. But remember that both sides of this equation are only determined up to a constant. So I have some unknown constants that I could add to one or both sides of this equation, and I'm just going to express that as plus C. In this case, I probably should have chosen a different letter rather than C, since C also represents our function, but I'm just going to distinguish them by always writing it as C of t rather than the constant C. Okay, so this I can rewrite, so this would be negative 600 times 3/4 times t to the 4/3 power plus C. Okay. And now I can simplify this a little bit further if I'd like to. So notice that I have a 600 and I can divide it by 4. So maybe let me write this in sort of a goofy way. So this I'm going to write as a 6 times a 100 times a 3/4. You can also just punch this into your calculator if you'd like, but I don't have one next to me, so I'm going to take the long way around. So I have a 100 divided by 4. I know what that one is. That's 25. And then this would be a negative 6 times 25 times 3. So that would end up being 6 times 25 is 150, and then times the 3. And that ends up giving me negative 450 t to the 4/3 plus C. You might have seen that right away, but for some reason my brain's not working. So this is what we get as our antiderivative. However, remember that we're still ambiguous up to this constant, so we don't know exactly what this constant is, but we can find it based on the information that's given to us in the prompt. So what we know is that there are currently 64,000 subscribers to this online fashion magazine. So here, this is meant to be the current number of subscribers, and we want to know how long it will take until the number of subscribers drops to this 46,000 mark, where t is the amount of time that passes from now. So the way that I would write this initial condition is like this. The current number of subscribers, in other words, the subscriber number at time 0, is equal to 64,000. So here you can be a little bit careful to pay attention to the units that you're using. So this 64,000 is describing the number of subscribers, and C of t is also describing the number of subscribers. So in other words, 64,000 is not going to be the input x, it's going to be the output, because the function that we're looking at as its output describes the number of subscribers. The input should be the time that's gone by. And in this case, we're saying at time 0, we have 64,000 subscribers, and we want to know the time at which the subscriber number will be 46,000. So first, I'll determine C by plugging in this information. What we know is that 64,000 is the subscriber number at time 0. Oops, sorry, this T should be 0, because we're plugging in a C value of 64,000 and a T value of 0. And because T is equal to 0, we're just going to get a C value of 64,000. So we know our C value now. this means that C of t is equal to negative 450, t to the 4/3 plus 64 grand. Okay, and lastly, what we can do is, now that we have C of t, we can answer the question how long it will take for that number of subscribers to equal 46 grand. So this is asking the question, what would the value of t need to be in order for C of t to equal 46,000? So what time is it whenever the output or the number of subscribers is equal to 46,000? So for that, we're just going to plug in the number of subscribers that we want, which is 46,000. And that will equal C of t. And C of t is equal to 450 t to the 4/3 power plus 64 grand. Okay, and now we can rearrange this equation. Sorry, I'm sort of running out of space here. We can rearrange this equation to solve for t. So if I rearrange, what I'll get is 450 t to the 4/3 is equal to, and then on the right side, I should have a 64 grand minus a 46 grand, which I think would be 18, no. Yeah, so we'll have 18 grand. And next, what we can do is we can isolate t. So here we'll have division by 450 gives you that t to the 4/3 power is equal to 18 grand divided by 450. And then if you raise both sides to the 3/4 power, then you would create a power of 1 on the left side, and on the right side you'll get whatever this is. So you'll have an 18 grand divided by 450, and then raised to the 3/4 power. Now, you'll have to forgive me, I don't have a calculator on me at the moment, but whatever this number is, that will give you the t value, or in other words, the number of months that need to go by in order to get the desired subscriber number. So that's what we get for the first one. So next, we are given a particular value for h, and we want to know the antiderivative of h. So this is the same thing as just asking what is, there we go, what is the antiderivative of x to the 1/2 plus 2 over x dx. Now, this might be a good time for you to pause the video and compute this on your own if you don't immediately see how to do this, because this is something that we've done similar examples to above. You might just pull out the list of rules that we have on the front page of the notes and see if you can complete this on your own. But I'll go ahead and progress. So I'm going to split this into the integral of two separate terms. For the first term, I should add 1 to that power. So a 1/2 plus 1 would be 3/2, and then I'll divide by the new power. Now for the second term, what I'm doing is I'm integrating, well, maybe I should pull out that factor of 2, and then I'm integrating a 1 over x dx. So this would give me a 2/3 times x to the 3/2 power plus, and then the integral of 1 over x will just become an ln x. And again, the technically correct thing to do here is to write absolute value symbols, but I'm not going to be super persnickety about that. The main reason for this is just that this integral can be defined for negative values of x, but ln does not exist for negative values of x. However, it will have the correct derivative if we just put this absolute value sign around the x. So this would be okay. And then just remember that we need this plus c at the end, because we're taking an arbitrary antiderivative, or an indefinite integral. So this is what we get. Okay, and I think what I'll do is I'll finish 6 in this video, and then our last video will be 7 and 8. So in problem 6, we're looking at this function y is equal to 2e to the negative 2t plus e to the t, and we're just trying to verify that that is a solution to this differential equation. So what I mean by a differential equation is it's some equation that involves a function and its derivative. So here we have this set of equations, really. We're just trying to make sure that this function, y is equal to 2e to the negative 2t plus e to the t, does satisfy both of these equations. So let's just check them separately. So first, I'm going to check that y prime plus 2y is equal to 3e to the t. So we want to see if the function that they gave us does solve this equation. So let's come up here and compute y prime just for convenience. So if y is given by this line below, then y prime would be, well, the 2 is going to stick around as we take the derivative. And then if you take the derivative of an exponential, you'll get the exponential function times the derivative of its exponent. So we would take the derivative of negative 2t, and that would be a negative 2. And then we also need to take the derivative of e to the t, but that would just give us an e to the t again. So y prime ends up simplifying to be a negative 4e to the negative 2t plus e to the t. So now we know y prime. Therefore, we can come back over and check by just plugging in y prime, which is negative 4e to the negative 2t plus e to the t. And then we're adding 2 times y, so that would be 2 times the quantity 2e to the negative 2t plus e to the t. So that's the left side of this equation. And now we want to simplify this a little bit. I can distribute the 2 here. So this would be a negative 4e to the negative 2t plus e to the t plus a 4e to the negative 2t plus a 2e to the t. And now these two terms cancel. I have a negative 4e to the negative 2t and a positive 4e to the negative 2t. So those cancel out, and all that I'm left with is an e to the t plus 2e to the t, and those would add together by just adding their coefficients. We'd have a 3e to the t. And that is what we have on the right side of this equation. So we do have that first equation holds. The second equation is going to be a little bit easier to check, thankfully. So we also want to check that y evaluated at 0 is equal to 3. So I'm going to plug in a t value of 0 into this expression for y. We'll have y evaluated at 0 is equal to 2e to the negative 2 times 0 plus e to the 0. So I'm just plugging in t equals 0 here. Now this would be 2e to the 0 plus e to the 0. Remember, anything to the 0th power is just 1. So that's a 2 times 1 plus a 1, which is 3. And that's exactly what we wanted. So this function that we were given is indeed a solution to this initial value problem. In this class, I don't think that we'll have time to talk about general differential equations that look like this, but we will sort of prepare you for a differential equations class, in the sense that we're basically looking at all of the framework that you need to start studying equations like this. But I think the careful study of equations that show up like this is probably outside of the scope of this class. So in our next video, we'll finish this set of notes